Exams are right around the corner, aren't they? And I know the pressure is building up. So, today we're going to do a super quick, super easy revision of one of the most important chapters, vector algebra. Let's make sure you can get full marks on this one.
Hello, my dear children. Welcome back. I'm so happy you could join me for this quick revision session.
Now, I get it. For a lot of you, this chapter can feel a little, complicated. But trust me, Vedas, it's one of the most logical topics out there. And by the end of this little explainer, you're going to feel so much more confident, I promise. All right, let's jump right in. First things first, we have to be crystal clear about the difference between a scalar and a vector. It sounds simple, but it's the foundation for, well, everything else. It really is this simple. A scalar is just a number. It's just a value, a magnitude, like your height, right? But a vector has both a magnitude and a direction. So if you push a table, you are applying a force, that's the how much, in a specific direction, that's the which way. So remember, scalar is how much, and vector is how much and which way. So now that we know what these things are, how do we actually play with them? Let's look at the basic rules of the game, starting with addition. You'll need this for a lot of exam questions. And that brings us to the triangle law of addition. Just look at this picture. Imagine you walk from point A to point B, and then from B to C. Now, your final displacement, beta, isn't the total path you walked. No, it's the direct straight line path from where you started, A, to where you finished, C. So vector AB plus vector BC gives you the result, vector AC. You're just connecting the start of the first one to the end of the last one. Of course, in an exam, we can't be drawing triangles for every single question. That's why we use the component form. Just think of I, J, and K as road signs for the X, Y, and Z directions. And the numbers X, Y, and Z, they just tell you how far to travel in each of those directions. So, if a vector tells you how far to go in each direction, how do you find its total length? You know, its magnitude. Well, it's just our good old friend, the Pythagoras theorem, in 3D. All you do is square each component, add them all up, and take the square root. That's it. Make sure you remember this one. It's a definite must-know. Okay, now for the really fun part, the products. The first one is the dot product, and I want you to think of this as your first superpower for solving vector problems, especially when it comes to finding angles. Now pay close attention here. This is so important. When you do a dot product of two vectors, the answer is not a vector. It's just a single number, a scalar. That's why it's also called the scalar product. And this formula right here, it connects the dot product to the lengths of the vectors and the cosine of the angle between them. This is a direct question they can ask, so please make a note of it. Okay, a formula is nice, but the real question is, what do you actually do with it? What kind of exam questions can you solve with this? This is your secret weapon for 3 key things. 1, finding the angle between two vectors. You just shuffle the formula around to find cos theta. 2, and this is a huge shortcut, beta, checking if vectors are perpendicular. If their dot product is 0, they are. Why? Because cos of 90 degrees is 0. And 3, finding the projection. It's like finding the shadow of one vector on top of another. Let's look at a classic exam question. Find the projection of vector A onto vector B. Step 1 is always the formula. A dot B, all divided by the magnitude of B. For step 2, we just calculate that dot product, and we get 10. Easy. Step 3, we find the magnitude of B, which is root 6. So our final answer in step 4 is just 10 divided by the square root of 6. See, it's just a simple process. Are you ready for your second superpower? This is the cross product. Now, if the dot product gave you just a number, the cross product, it gives you something brand new and very, very useful. Now, here's the biggest difference. The result of a cross product is another vector. And the most amazing part, this new vector is perpendicular to both of the original vectors. Its magnitude involves the sine of the angle, and that little n hat you see, that just means the new perpendicular direction. But wait, perpendicular could be pointing up or it could be pointing down, right? So which one is it? For that, we use the right-hand thumb rule. It's so cool. Just point the fingers of your right hand along the first vector, A. Then curl them towards the second vector, B. Whichever way your thumb is pointing, that's the direction of your new vector, A cross B. Go on, try it right now with your hand. It actually works. So once again, the million-rupee question. What exam problems can this superpower help us solve? Here are the top 3 uses for your exam. Number 1, and this is a very common question, find a vector that's perpendicular to 2 other vectors.
You just take their cross product and you're done. Numbers 2 and 3 are for finding areas. You can find the area of a triangle or parallelogram. In fact, the magnitude of the cross product is the area of the parallelogram, and for a triangle, it's just half of that.
Now, actually calculating the cross product can look a bit scary, but there's a really simple, mechanical way to do it using determinants. You just make this little 3x3 grid, put I, J, and K hat in the top row, then the parts of vector A in the second row, and the parts of B in the third. Then you just expand it. It's a method that always works and gets you the right answer without having to think about angles.
Phew, we've covered so much so fast. So before we wrap this up, I've made a little something for you, a final cheat sheet. This one slide has every important formula you need for that last-minute look before your exam.
Let's do a lightning-fast recap. Magnitude is for length. Dot product gives you a scalar number, and you use it to find angles or check for perpendiculars. Projection is for finding a vector's shadow, and the cross product gives you a new perpendicular vector, perfect for finding, well, perpendiculars and areas of triangles and parallelograms. That's it. That's the whole chapter. Go on, take a screenshot of this. It will really help.
And just like that, you've revised vector algebra. See, Beta? It's not that hard at all. It's all about knowing which tool to use for which problem. You have worked so hard, and you are ready. Walk into that exam hall with your head held high. All the very best, my dear children. You are going to do wonderfully.